Hello everyone and welcome to the Build at Scale Lab. In this video, we will be going over how to program this Fetch AMR. We'll start by giving a brief overview of what fleet management is for AMRs, and then we'll dive into the details of FetchCore, which is the fleet management system for these Fetch robots, in great detail. We'll go over maps and annotations, robot status and how to clear any errors that arise on the robot, how to drive the robot around with a joystick, how to program workflows for the robot, how to schedule those workflows, and we'll introduce a topic called triggers, which is an integration technique to trigger actions for the robot. So what is a fleet management system? Well, when you're in an environment with AMRs, typically you're going to have more than one. You'll have several, possibly even hundreds. That's why manufacturers of AMRs provide what's known as fleet management software. Fleet management software, as the name implies, allows you to program robots as a unified fleet rather than having to program each individual robot.
All right, so this is FetchCore. FetchCore is a cloud-based software, meaning that Fetch themselves are hosting the software on a server, and then we are actually accessing it through the internet. So this is just a Chrome browser. I put in the URL, I have the proper login credentials, and we can use the entire fleet management system. So I am briefly going to go over the general responsibilities of a fleet management system. This is sort of agnostic of what the particular fleet management system is. They all, depending on the brand, they'll have different fleet management systems, and they all typically sort of follow a similar pattern of what responsibilities they have and the things they do. So I'll run over those real quick, and then we'll go over the actual implementation of how to do those things, specifically in FetchCore. So the first responsibility of a fleet management system for AMRs is to share maps between the different AMRs. So when you get your AMR, you're going to take it out of the box and you're going to drive it all around and just going to make this map. You don't want to have to do that for all of your robots in exactly the same way when you add a point on a map. So I'll just do this real quick. I'll add a point and I'll put a point here. I want all of my AMRs to know where this point is, right? I don't have to reprogram that point for all of my AMRs. So by having a shared map, we can avoid having to reprogram each individual AMR. They all have the same definition of objects in space. The second major responsibility of a fleet management system is task delegation and scheduling. So basically they tell what AMRs to do what when. So in FetchCore, that's handled via workflows, but basically these are housing the logic of what AMR should do what task, and we have a scheduler here that schedules when those tasks should be performed. The third thing that a fleet management system does is state monitoring. So in here, in FetchCore, you can do that under the Robots tab. So I can look at my AMRs and see what it is that they're up to. So I can see here that Jerry, which is the one with the Cart Connect module, is idle, and Tom, which is the AMR with the roller top, is mislocalized. So if I was in a production environment, I'd be monitoring this and I would see, oh, my AMR is mislocalized, I'm going to fix that. And so I could actually, reset the location and fix that issue. The fourth thing that fleet management does is collision control. This is not something that you'll actively program in the fleet management system, but it's something that most advanced AMR brands are doing under the hood, is because in a fleet scenario, you have a bunch of AMRs running all over the place. And you've probably seen what happens when two starships are taking up the same piece of the sidewalk, is they'll do this kind of jerky thing where they'll sort of get stuck against each other, and then they'll both try and go the same way, and it gets really awkward. So in a production environment, you would really want to avoid something like that. It can cause like AMR traffic jams, and it can cost you a lot of time and lost efficiencies. And so it's really important that AMRs have some way of managing the traffic, and the fleet management system sort of is like that intermediary between the robots saying, all right, you need to slow down so this AMR can go around you, or you guys are going to run into each other, like you're on the same path. Don't freak out. You both will just go right and go around each other, right? Otherwise, if you don't do that, they'll get close to each other and they might think it's a person, they might think it's an object of some kind that's in their way, and they'll just continue to get in each other's way. So having some sort of mediation system to handle traffic is another really important aspect of fleet management. But again, that's something that they should handle under the hood. You don't really program that yourself.
Now that we've gone over the basics of what a fleet management system is and what it's responsible for, let's go into the details of how to actually use these robots, starting with simply how do we drive them around with a joystick. This is what Fetch calls a joystick. Basically, it's just a game controller that you can use to drive the robot around manually. This is useful for all sorts of things. If you get the robot in a jam and just need to manually drive it to a location, it's super helpful. It comes with this little USB stick that you plug into the robot so you can use the controller. So I'm just going to take that USB and plug it into the side of the robot and then turn the controller on. Now all the buttons on the controller are labeled, which makes it super easy. The most important thing you need to know is the dead man switch. That is this trigger here on the left. You have to hold this down for the robot to move at all. If you don't have this trigger pulled down, the robot will not move. If you hold the trigger down and then hit this joystick here on the bottom right, this is the forward/reverse, the robot's going to move. And then you can rotate it using the top left joystick. In order to raise and lower the spikes for the cart connect, that's what the Y button and A button are for. So if I hold this down, the spikes go up. And then if I hold the down button, the spikes go down.
So one final but very important step of using the joystick is making sure that when you're done with the joystick, that you disable it. So you'll notice that the lights are, once you unplug the joystick, the lights will still be flashing on the robot, and it won't actually take any commands from the fleet management system, and it'll just sit there. It'll only take commands from the joystick. The only way that you can get the AMR to once again take commands from the fleet management system is to do it from inside the fleet management system itself. You have to navigate to the robots tab. You can see here the state of the robot says it's joystick. So you have to hit disable joystick, hit continue, and then if you refresh the page, oh, there you go. And it's actually mislocalized, which is very typical. Once you've used the joystick, the robot will lose track of where it is. And so a lot of the time you'll have to reteach it its location. So I'll actually just show you that process right now. So I'll just hit reset location. And then I just drive the AMR to where I think it is. And so in this instance, I'm actually pretty certain that it's like docked and it's right here. So I'll just hit localize. It's thinking about it. There we go. All right, so now the robot has found its place in the world again, and all is well. And this brings us to the topic of clearing errors. The robot may error out for a number of reasons. It may lose track of where it is. There may be a piece of dust on the LiDAR sensor, so it hallucinates an object that doesn't exist and it gets stuck. Maybe you left the cart on the robot and it can't escape the cart because it doesn't realize the cart is actually on top of it, and so it's just kind of trapped in a cage. And sometimes robots are robots and they just don't do what they're supposed to. Like in this clip, it just, for some reason, really struggles to find its spot on the cart. Sometimes this sort of things just happen, and so the robot will fault out, and so you'll need to know how to clear those errors. Whatever the case, just click on the Robots tab, click Clear Error. It'll give you the error message. You can hit Clear Error Status, and then when you refresh the page, yep, the error should be gone. All right, so now let's talk about how to use the map in FetchCore. So when you unbox these robots for the first time, you'll take them on a walk of your environment so they can get a lay of the land and make a map of the space. Once you have made the map, you can then access it in FetchCore. FetchCore does support multiple maps, so it's important that you have the right one selected. If you hit the Switch Map button, you can choose which map you want. For the lab, you should have this robotic integration lab map selected. This is our personal one that we use for like demo loops and stuff in the lab, so just make sure that you have the robotic integration lab map selected. When you get here, it should look like this. It is important to note that a robot can only be assigned to one map at a time. So if you'll notice, there are no robots assigned to this map. But if we go to the robots tab and I find Jerry, under settings, we have Matt, and I can say, I actually want to assign this robot to the robotic integration lab map. Now when I save this, and I go back to my map, now you can see Jerry shows up under robots. And here he is. He's localized himself in this map. All right, so we have our map, we have our robot. Let's add some features to this map. So fetch calls features that you add to the map, like points and positions and rails and things like that. They call them annotations. And you can add them or edit them in this Edit Annotations button up here in the top right. So if I click that, it'll give me a list of options to choose from. So we'll just go through these left to right. The first option is position. This is pretty straightforward. It's just a position that you can tell the robot to go to. There are two types of positions. The first is the standard Freight 100 robot position. This is if you want to tell an AMR to go to a place, you will use this annotation. So you can put as many down as you want, and if you hit escape, it'll take you back to the standard editing mode. And then if you click on them, you can even change the orientation. So theoretically, when the AMR goes to this point, it should respect the orientation and be facing that way. That does not always happen in practice. Sometimes it'll be flipped 180 degrees in the wrong direction. But yeah, it kind of varies from case to case, it seems. So that is the standard point. And then the other option under position is the freight cart position. So these are places where you want to either pick up or drop off a cart for the cart connect. You cannot simply tell an AMR to go to one of these places and not pick up or drop off a cart. To use one of these positions, they always have to be picking up or dropping something off in the position. So if I set this down here, let's say I want to have the AMR come and pick up a cart here, and then I want it to go to a position with the cart still attached, maybe here. And then I want to have it drop off the cart over here. I could make a flow saying, okay, go pick up the cart at this position, now go to this position, and then drop it off here. And so it'll actually disconnect from the cart connect here, and then I can send the AMR off to go do something else. Those are the positions. So the next thing that you can add that you probably won't have to mess with are fixtures. These are objects in your environment that are in a fixed location and aren't going to move and that the AMR needs to interact with. So a charge dock is a pretty straightforward example. You need to tell them where their docking stations are so they can go and use them to charge. So you can see we've already added one over here. This is your charge dock 001 that Jerry can use. There are a couple other fixtures, but you won't have to worry about these for the lab. Paths are pretty important. They're just like lanes that you can set for a robot. So I can draw a path here, and that way the AMR will follow this path as closely as it can. And I can even edit this to say that it shouldn't deviate off this path at all. So if this is not, if required path is disabled, the robot will do its best to follow it, but if something is in its way, it'll drive around it. But if this is on, it basically means that the robot is going to stay on it like it's on rails. And if something stands in its way, it's just going to get stuck. So useful to use both modes depending on the situation. If you have a super narrow corridor that you know there's no way the robot should deviate around anything, setting it to path required is definitely recommended. But in a scenario where we have like a lot of leeway and traffic, or things that the AMR may need to drive around, then you definitely want to leave required path disabled. You don't have to use the paths in this lab, but if you would like to, you certainly can. Two-way path, this is just for traffic control purposes. If you want the AMR to be able to go this way and go back on the same path, you can set that up. Because the one-way path will as you can see, it's directionalized, so the AMR will only drive on it in this way. It will not try and start here and go back this way. So that's the difference between the one-way and the two-way. Zones are different kinds of zones that you can set. The keep out zone is the big red one. Basically, the AMR should not go in here for any reason. Pretty self-explanatory. You can either draw them as rectangles or you can make your own sort of polygon shape by setting a bunch of points to make funky shapes. But yeah, so you have keep out zones. You also have obstacle free zones. These basically, I believe they just tell the robot that, yeah, this is just a totally designated AMR zone, and so they can crank up the speed and not have to worry about running into anything as much. Don't use this because we don't really have any places in the lab where that is the case, because this is a very mixed use environment. Speed limit zone, if you want the AMR to slow down, because you just have an area where there's a lot going on, you don't want people to trip over the robots, or it's just high traffic and you need the robots to slow down, you can use these, and then you can set whatever that speed limit is. And then also narrow passage zone, it's kind of the opposite of the obstacle free zone. It just tells the robot to just be extra careful and not try and deviate too much from its path. And then text, I think, is just so you can mark up the map if you want to add labels to things, but you don't need to do that. So yep, that is all of the annotations that you can add in FetchCore. So now that you know how to add and edit these annotations, let's program the robot using workflows. So let's program our first workflow. So the workflow that we're going to program is we're going to have the robot pick up the cart that's in this position. We'll have it drop off the cart in this position, drive it back here, pick the cart back up, drop it off here, drive back here, and then we'll start the loop over and over and over again. We'll just run it as a loop. So how are we going to do that? Well, you go to the Workflows tab and go to Workflows v2. Just ignore the standard workflow tab. That's like Workflow v1. It's depreciated, so don't use it. Just use Workflows v2. We'll click New Workflow. First thing you need to do is tell it which workflow you want, or which map you want that workflow to run on. We want it to run on the Robotic Integration Lab, and we will call this lab workflow. So you probably noticed this block that was generated for us. This is called an action group. An action group is a list of instructions for the robot. So underneath this block is where you'll put all of your code for how you want the robot to behave. So I'll go back here and look at the map. First thing I want to do is pick it up here, drop off the cart here, and come back here, right? So what we can do is say navigation to go to a position, right? But actually we want to go under cart connect. So under robot specific actions in cart connect, we can say pick up cart at cart position, right? So if I grab this block and put it under here, first thing it's going to do is we'll say go pick up the cart at position 001. That's where the cart is right now. And then we want it to drop off the cart at position 2. So we'll go to cart connect and say drop off cart at cart position 2. And then we want to say navigation, go to robot position 1. So pick up cart here, drop off here, come back here. And then we're kind of going to do it in reverse, where we will have the cart picked up at position 2 and then drop off at position 1. And then we'll just have the robot return to position 001. So go to navigation, go to position, go here. Now let's talk about the action group block in particular. So the first thing that we're going to do is actually just name this. We will call it cart loop action group. But the action group block itself does two things. It determines when this code should get executed, and it determines on what robot the code should execute on. So those two things. So there's three options for when you should run this code. It's immediately on trigger and on equipment trigger. Immediately basically just means whenever the action group is scheduled. So I'll show you the scheduler. FetchCore has this built-in scheduler feature. So it's, instead of the workflows tab, you'll come over here to scheduler. And this is where you can schedule your workflows. So if I hit this new schedule, you can choose which workflow it is you want to schedule. And we'll do that in a second. But basically, whenever it's time for a workflow to run, this action group will kick off. And it will start immediately. And it will run on all robots assigned to this action group. And it will run this continuously. So I'll go ahead and save this workflow. So we have the robotic, on the robotic integration lab map, we have the lab workflow. And so if I go to the scheduler, I'll just refresh to make sure all the changes have gone through. If I click on new schedule, we have lab workflow right here. So I'll click on that, go to next. And it's just like Google Calendar, right? You can just tell it when you want something done. Let's start it at 4:31. We'll never repeat it, so we'll just say next. And then we want to assign this action group cart loop to Jerry, because he's the only cart connect robot that we have. We'll go next, and then save schedule. And now it's here. So now at 4:31, it should start our lab workflow and go pick up the cart, bring it to position 2, drop it off, pick it up, drive it to position 1, drop it off, and then this should just get repeated in a loop. So while we're waiting for that to happen, the other things that can trigger an action group are a trigger, which we'll go into in much greater detail in the next video, but that's for an external piece of software to tell FetchCore to do something. So it'll basically hit a URL, which will tell FetchCore that an event has happened and you can handle that event here. So if I go to on trigger, I can choose a trigger schema. I don't actually have any applied to this map, but we will in the next video set one up. So I would choose a trigger off of this list, and then whenever I hit that trigger, it'll start running this loop. But I'll just say run immediately when scheduled, all robots in this pool continuously. You could also have it run just one time. And on equipment trigger, you can add equipment into FetchCore. We won't go into that much in this lab, but you can actually have like physical pieces of equipment like conveyors wired into FetchCore, and you can catch signals off of those and then trigger action groups that way. But for now, we'll just have this demo workflow. And if I go back to my map, we can see Jerry is working. It looks like he just dropped the cart off. So I'm actually going to go out and I'm going to film what's going on, and we can see if our workflow is working as expected. All right, and so this is a sped up video clip of that workflow in progress. So we're picking up the cart at cart position 1, and now we will be driving and dropping the cart off at cart position 2. So that's cart position 2. Dropped off the cart. Now it's driving to robot position 1. And now it should drive back to cart position 2 to pick up the cart, and then it'll drop it back off at cart position 1. So again, this is sped up, and if you see any jump cuts in the video, it's because sometimes the AMR will just sit there for a little bit in between different tasks, and so I just cut some of that out. So one thing you may notice is that the AMR will be really skittish when it's carrying the cart to approach objects. So in this case, the cobot pedestal, it's approaching very slowly, but eventually it'll get there, and it will drop off the cart and exit. And that'll do it for this video. In the next video, we will cover a lot more of the integration. So we'll tie in Node-RED. We'll talk about how to trigger these action groups through Node-RED, as well as how to capture when these action groups have completed in Node-RED as well. But that's it for this video. So thank you guys for watching.